lessons on continuous time Markov chains. So, get a piece of paper and make two columns, one for discrete time Markov chains, the other for continuous time Markov chains. So here's the deal. Discrete time Markov chain, we might have, say, 3 states. And we have some discrete time interval. So every day, every hour, every whatever that time interval is, we are going to check our state. And we could be in, say, state 1, state 2, state 0. We have transition probabilities. They're the probabilities that we are in any given one of those states at any given time, or that we transition from any one of those states to another state in one step. Okay. Now, continuous time Markov chains, big difference is obviously continuous time, not discrete time. So instead of having this discrete interval and saying, okay, what's our status today? What's our status tomorrow morning? Now we're going to say, all right, my system is in state 0. So how long is it going to take until I transition in state 2? I'm never going to have this 0 and 0 because the probability of, in the continuous time Markov chain, the probability of staying in a state is 0. We only care about it when it actually transitions. So that's a little bit of the intuition. Similarities and differences. So similarities. Both have a memoryless property, the Markovian property. And both of them have stationary transition probabilities. In other words, you're still going to have probabilities of going from one state to another state. But you're also going to have stationary rates. We'll get to that in a second. Okay, so there are your similarities. Now, this is where you need your piece of paper with 2 columns on it, because we're going to talk about the differences. So, discrete time Markov chains versus continuous time Markov chains. Number 1, obviously, continuous versus discrete time. Okay. Another one is that you're going to have transition probabilities, where you're going to have Pij is the probability of transitioning from state I to state j in one increment. Okay, so these are going to be transition probabilities. In the continuous time Markov chain, we're concerned about Qij, which are transition rates, the rate at which you transition from state I to state j. So probabilities here, rates here. Okay, these are going to go into a matrix we're going to call P for discrete time Markov chains, and for continuous time Markov chains, we call it Q. It's also called the infinitesimal generator matrix. And with a discrete time Markov chain, you can stay in the same state. So Pii can be greater than 0, whereas in the continuous time Markov chain, you cannot stay in the same state. So the probability you stay in state I is going to be 0.